Hi, BotConf. Are you all awake? Who is here the first time? A few newcomers. Who has been here every 4 times? Yeah, so some people already know me. For the others, my name is Ueltschi. I've been working for SwissPostCert for over 9 years. Recent focus is on malware analysis, threat intel, threat hunting, red teaming, and I've been previously talking about BotConf for a few years, and some people may know me from trusted groups and communities that I'm active in. My Twitter handle is on here, so if anybody wants to get in touch, or they can get a card with an email. Brief disclaimer, views and opinions are my own. The work presented is from my day job, but I also put a lot of free time into preparing this content. It's mostly just ideas and examples, kind of a methodology that I would like to present. It's not meant as a finished product or solution, but something that other analysts can adopt. The slides will become available, and all the public resources are linked in the references slide at the very end. So I was having a hard time ordering the content, and this is the best I could come up with. First, introduction about Sysmon and in general, and then trying to detect known bad by looking at different sources for knowing evil. So we'll go through all these, and at the end some threat hunting approaches from red and purple teaming. If you haven't read the abstract yet, the main goal is to share an approach or methodology how to greatly improve host-based detection using the free Sysmon tool. So a quick introduction on Sysmon. This presentation is about version 3 of Sysmon, the latest version. There has been a version 4 out for some time, and version 5 was just recently released and added many useful new event types, which I'm not covering today. So this talk is about host-based detection. It's not about prevention, and it's not about network-based detection. There's a lot of other products in that space. I would put this approach in the EDR space along with solutions like Carbon Black or others. So which is better, network-based or host-based detection? I guess that's an opinion. In my opinion, you need both. For some things, network-based may be better. For other things, host-based may be better. I would like to compare this approach with Bro for network-based detection. So Bro has a platform, it has a programming language, and it has apps on top of that. So Sysmon and Splunk, putting your Sysmon data into your SIM, that could be the platform. And Splunk as a SIM has a powerful query language, and on top of that you can implement searches, alerts, and hunting as use cases. So that triangle kind of reminded me of the pyramid of pain, so I just threw in this slide because I think that should be mentioned in every good talk. I would like to be able to detect tools and TTPs, which are most challenging. And there also should be a mention of the cyber kill chain in every good talk. So here's that slide. That's the only mention of cyber. And I would like to be able to detect all post-exploitation phases from the kill chain. And just to show you that these two models go well together, this is a good blog that you should take a look at. So why using Sysmon? Sysmon gives you incredible visibility into system activity on Windows host, and it's free. Having this great data available in your Windows event logs for investigations and forensics is really useful. However, if you can ingest Sysmon data in your SIM, it's even much more useful. But your analysts need to know what to search for, what's normal or abnormal, what's suspicious or malicious. Every company network is different, and what works at one company may not work at another at all. Mark Rusinovich is one of the authors of Sysmon, and he gave a great talk at the RSA conference. I definitely recommend checking this out. Oops, too far. These are the Sysmon event types from version 4. And this presentation focuses mostly on 3 of them. Process create, network connections, and create remote thread, which is used for DLL process injection. So some interesting fields for process create are image path and command line for the process and its parent process. The different hashes which can be configured, and the user starting the process, and the process GUID, which can be used to correlate with other event types. Some interesting fields for network connections are image path, user protocol, and if this host initiated the connection or not. And also the IP, host name and port for the source and the destination, and the process GUID to correlate with other event types. For the create remote thread, the interesting fields are source and target image for injection, and the process GUIDs for source and target process for correlation. There was also a link to some examples which have been shared on the Splunk blog, and there are some other examples out there. So when I tweeted to Mark Rusinovich thanking for the presentation and mentioning that we're about to deploy Sysmon, he actually said it's cool to see people using Sysmon at scale. So here's a brief high-level overview of our deployment. Sysmon and Splunk Forwarder are installed on all workstations. I put a lot of effort and time into tuning the Sysmon and Splunk Forwarder configs to filter some data before it's stored in the event log and before it's sent to Splunk. We have this deployed on over 20,000 hosts and ingesting between 15 and 20 gigabytes of data into Splunk per day. So now the big question, how do you know evil? Can you distinguish between good and bad, normal versus abnormal, suspicious and malicious? One good source for knowing evil is OSINT and public resources like blogs, threat reports, public sandbox analysis, VirusTotal, papers and reports from the DFIR community. A couple of years ago, SANS put out this great DFIR poster, no normal, no abnormal, find evil. They were actually handing those out on the SANS table yesterday and today, so if you want to pick one up. So many of the mentioned anomalies when searching for malicious processes can be implemented using Sysmon. Parent-child process relationships, command line arguments, wrong or known malicious image path, just a few examples. But to repeat, let me quote, in an intrusion case, spotting the difference between abnormal and normal is often the difference between success and failure. So one of the examples for knowing normal is SVC host exe. It only has one legitimate parent, which is services exe, and there's only one legitimate path, and it's always started with a -k parameter for grouping services by name. So just knowing that as an example, you can implement a search and an alert for SVC host exe processes which are missing a -k parameter, were not started by services exe, or are running from the wrong path. If you don't have too many Windows versions, you can even whitelist the known good hashes in case if SVC host exe was abused as file name for a totally different malware. This is a blog post from early July about a Java rat which had 0 detections from AV. The virus total analysis was linked in the blog, and indeed the initial detection rate was 0. A couple days later, there were 8 AVs detecting it. And in the comments on virus total, there was the public sandbox analysis linked. So just continuing with OSINT, we can look up that sandbox analysis, and which shows a detailed process list with full command line parameters. Since I've seen and analyzed Java Adwind rats before, we already had detections for several behaviors from this malware. This alert is detecting any of these behaviors. A VBS script with retrieve random VBS being executed by C script. Xcopy being used to copy the legitimate JRE to app data. And Java being started from that illegitimate path, which I've never seen used legitimately. And this one is for detecting persistence method, regadd being used to create a registry key, a run key for persistence. So we have a separate detection for this as well. At the beginning of November, Didier Stevens blogged on SANS ISC about a new Hansitter variant which bypasses application whitelisting. On his own blog, he wrote more details about process hollowing technique used. The doc malware sample discussed on the blog was first submitted to VirusTotal on October 26. I went through my own analyzed samples and were looking for similar behavior. I found the same sample as on the SANS blog was mentioned, but also other samples which were up to 6 days earlier analyzed. So the common behavior is Office process spawning a system process like Explorer exe or SVC host to be abused for process hollowing. This is our own malware analysis report showing that WinWord spawns an Explorer exe and then injects into that DLL, injects a DLL into that process. This is the analysis from 6 days earlier. So we can create an alert for Office processes spawning a system process. For WinWord or Excel, I haven't seen any false hits for WinWord, but Excel seems to have some feature which spawn Explorer exe, so we had to tune that a little bit for Excel. And this alert detects process injection from Office processes into a system process. So this is the event ID for create remote thread. After I finished the slides, I found out that the process hollowing technique actually doesn't use create remote thread, but it uses something that can be detected with the newest version of Sysmon. So I'll start look into that, because this detection won't actually detect the process hollowing technique. Now, one of the most valuable sources for knowing bad is my own malware analysis on samples from our own quarantine, which are blocked at my company. This is a high-level overview of our automated malware analysis process. Inputs are emails or files where attachments are extracted and decompressed if necessary. Then the sample is uploaded to a sandbox and the analysis results are downloaded when it's finished. The post-processing is extracting files, registry keys, process created with full command lines, DNS, HTTP requests, TCP connections from the PCAP. Then Yara rules are matching on files, memory strings, and PCAP. And then I started creating some behavior analysis to look for specific patterns, and which then I create Splunk searches and alerts out from those behavior rules. By now I have created more than 180 behavior rules, over 50 detect process activity, which I mostly use for Splunk searches and alerts, but others detect file system network, registry activity, or different persistent methods used. Now let's take a look back at the Java Adwind. From 132 jar samples analyzed, 122, over 90%, would be detected by the regadd persistence method, which I've seen used since January 2015. And 118, almost 90%, would be detected by one of the other two detections using Xcopy to copy the JRE, or the Java process being run from that illegitimate directory, which I've seen used since October of last year. Now let's take a look at some keyloggers and password stealer families. Here are 5 keylogger families which all use the /stext parameter, running some executable and giving a txt file as a parameter after that. The txt file names vary between different keylogger families, and in red are the number of samples analyzed per family. Our own analysis, almost 350 in total. They also all have in common that they abuse the Nearsoft tools for password recovery. So just doing OSINT, I found this keybase logger analysis where the stext is used 4 times with 2 different txt files after that. Looking at the emerging threat IDS detections, it confirms that it's a keybase sample. This is another sample from iSpy keylogger, which was using stext parameter 4 times with 4 different txt file names. And here, looking at the memory strings, I can also confirm that it's iSpy keylogger, which is the same thing I'm doing with my Yara rules on the memory strings. So with this very simple alert, just looking for /stext in the command line, we can detect at least the 5 mentioned keylogger families. But why do they all use the stext parameter? I asked this question to Google, and I got some good hits. One was the Google book, 7 Deadliest USB Attacks, which had some interesting information. Nearsoft's mail password viewer uses a /stext parameter. The IE password viewer uses an xtext parameter. The product key recovery uses stext parameter, and probably some more. I just recently found another keylogger family which uses s comma instead of stext, or others use -f with similar similar patterns in process, just different parameter names. So now let's take a look at ransomware, especially Ueltschi, which has been heavily spammed out this year. I try to almost daily analyze at least one sample from each mail spam run, which is blocked at work. Then I look for changes in behavior and adjust alerts accordingly. Let's take a look at two Ueltschi samples from April and August of this year. This Ueltschi samples drops and runs an exe from temp folder, which then calls VSS admin delete shadows all quiet to delete the shadow copies. At the end of the infection, a ransom note is opened in the browser. With this alert, we're just matching VSS admin delete shadows in the command line, which has also been used by other ransomware families. In late August, Ueltschi started dropping a DLL in the temp folder and starting it with the run DLL exe and a QWERTY parameter. Some variants added a number after that, but that's not always the case. So with this alert, detects a run DLL32 process with either temp folder, which is used for the DLL, and the QWERTY parameter, or it looks for the parent process. If the parent process is one of the applications which are used to spam out most of the attachment types, JS, VBS, HTA, and even macros, that would be covered by the parent process. So these are some of the behaviors detected from Ueltschi samples. It was dropping Ueltschi, Septa, Odin files earlier, and these two HTML file names, and using the two behaviors that I just discussed. Also, with my YARA rules over the PCAPs, I detect the different URI patterns used for the post requests of the CNC traffic from Ueltschi. Here you can see which URI pattern has been used for how long, the first and last seen sample. And also in September sometime they started XORing the DLL being downloaded, and this detection just looks for known XOR keys in the PCAPs. So it's not a generic detection. So after I made some of the slides, there's an update. On October 24th, they used the shit file extension for a couple days, and they changed the HTML file name for the ransom note. And they changed the URI pattern, and they started changing the QWERTY parameter for the DLL function to something else. And a couple days later, they started using the Tor extension, no more shit. And here in November, they started really changing the function name for the DLL very frequently, every day or every spam run. Once they had a sample that had a .44 extension instead of a DLL. So the QWERTY detection would not be useful anymore as it was for the 2 months before that. Now let's take a look at malicious PowerShell usage. Everybody loves PowerShell, right? This is a Ueltschi sample that uses PowerShell web client download file and some obfuscation to download the payload. this variant was dropping roaming exe, which is on the same in the app data where the roaming directory exists. And this is the behavior rule for PowerShell web client download file. This was from a spam run on October 17th. These are the mail headers, mail attachments, a JavaScript inside a double zipped attachment. And you can see that it's dropping these executables, including the roaming exe. And this was the URI pattern that was used. So here's an alert detecting PowerShell web client download file, which has been used by malware for some time. The obfuscation in the CMD command line doesn't exist in the PowerShell anymore. So this is the PowerShell command line, and you can match that looking for web client download file. The PowerShell web client download file behavior has been seen in over 80 samples since February of 2015. And the PowerShell obfuscation was just started in end of September this year. They started adding the caret symbol in between of the command line. On November 10th, I saw a sample which was an LNK file embedded in a docx, so no macros used. The user had to double-click the embedded file. And they used a new trick. They actually split the download file in two substrings and used string concatenation. So the alert initially didn't match any longer. So I added a simple deobfuscation to my Splunk query, just removing certain characters for obfuscation to fix this trick. And the download file in the deobfuscation would match the string that I'm looking for again. So do you think this solves all the obfuscation problems in PowerShell? Well, the answer is not really. If you look at this great presentation from Daniel Bohannon, Invoke Obfuscation from the DerbyCon, he shows a lot different obfuscation techniques that can be used with PowerShell. And this simple solution I showed before is not solving all of them. In fact, on November 18th, I saw another sample which used another trick. You could call it string replacement because it uses variables for string. And so here, the download file was split in 3 parts, one of them inside a variable. And with the string replacement, even the deobfuscated string doesn't match the download file anymore. So you have to add like a deobfuscation script into the search. So now let's take a look at some threat hunting approaches. This is the threat hunter profile of David Bianco. I'm a big fan of his work. He also invented the pyramid of pain. He has a good definition of threat hunting. Hunting always involves a human. David also created a web page for the threat hunting project. I definitely recommend taking a look at it if you're interested in threat hunting. The project has many so-called hunts, techniques how to hunt, indexed by goal, for example, lateral movement or privilege escalation. One hunt, for example, is lateral movement detection via process monitoring, where you can search for a number of legitimate system tools used and commands executed within a short time, typically used by attackers during lateral movement for initial recon. Another hunt is to look for process creation from tools commonly abused by attackers, which is kind of similar to the previous one. And at the end of this, he says, Sysmon is a very good free tool that can do nearly anything you need. So that made me happy. So another source for knowing that is adversary simulation or red teaming. Cobalt Strike is a commercial tool which is great for red teaming and adversary simulation. The creator of Cobalt Strike also put out a 9-part video series which is available on YouTube about advanced threat tactics and red team operations. Even just watching those videos gives you a lot of information, what you could look for, how to spot an adversary. 2 videos are about privilege escalation and lateral movement, which is pretty much all you need once you have a foothold in a network to do pretty much anything you want. And if you haven't heard or looked at Bloodhound, that's a great tool that was released during Black Hat this year, which kind of shows or helps you discover all the different paths that an attacker can take inside your network using privilege escalation and lateral movement. With Malleable C2, you can make your HTTP traffic look like totally legitimate and bypass and evade all IDS detections. So in this case, network-based detection would be not perfect. Cobalt Strike makes heavy use of PowerShell and its features. But when using Cobalt Strike, an attacker or red teamer would also use system commands like whoami/groups as an example, which can also be detected. There are several techniques available for lateral movement in Cobalt Strike. One of them is similar to PSEXE. PSEXEC uses the dollar shares like admin C or IPC dollar. And a lot of features in Cobalt Strike make use of DLL process injection, which can also be detected with Sysmon. And even the keylogger feature uses process injection, which can be detected. Another feature is the internal peer-to-peer communication between compromised hosts using named pipes over SMB. This allows for one host making egress traffic and reaching hosts which are not connected to the internet. So, doing on time. Okay. Running late? Okay. First, you need to know a few things before you're ready to hunt. So, can you distinguish between workstations or servers inside your network? And if you can do that, you can create a search looking for SMB traffic between workstations, which is possibly or hopefully abnormal in your network. And you could detect using named pipes over SMB inside your network. This one is actually the Sysmon data from PSEXEC in Cobalt Strike. You can see services exe spawns randomly named executable under admin $share, which then starts a run DLL32 process, and then it does process injection into that run DLL32 processes. So each of those steps can be detected by using Sysmon. You can create searches or hunts for that. Also, the keylogger being injected, like from the run DLL32 process into win logon, you can create a detection for that. And there's some more ideas for hunting. For example, looking for the rarest processes connecting through the proxy, or for PowerShell encoded command, which is also heavily abused by malware and attackers. Just briefly, the red part is looking for network connections from processes under the user's profile. And then it correlates the process GUID back to the process create event. And then you can look how many clients have this process running, for example, by import hashes. And if you're not familiar with import hashing, this is a reference to the Mandiant blog that discusses this concept. And here is the PowerShell encoded command detection, where you look for PowerShell -enc in the command line and remove the encoding, which would match that. And then you actually see encoded commands from PowerShell being used. You can use this for hunting, for alerting, and probably need some tuning. Brief conclusion, I've shown you how to search and alert for known malicious using image path, image names, command line parameter, parent-child relationships, process injection, and how to do hunting for lateral movement using admin shares, internal CNC over name pipes, the rarest processes connecting through proxy or suspicious PowerShell activity. I have countless more ideas, and I was actually asked to contribute to the project, threat hunting project, so I may actually do that. A few people to thank for their contributions and products that I've been happily using. And thank you for your attention. And time is probably up, but if we have a question or otherwise, come talk to me, find me later. I'm happy to discuss anything about this talk with you. Looking for some feedback.
We have time for half a question. Okay, there. That's one.
Thank you for this great presentation. I will discuss details further because I'm in a firm where we have very similar problems and we are using Splunk. My half question is the following. How did you realize some triage with the flood of events you would have into Splunk? There we tried actually some years ago to install Splunk on every desktop, and the fact is that there are a lot of events. So
yes, that's the lot of work I put into the configurations like Sysmon config and the Splunk forwarder config to really reduce the noise, the amount of data you put into the event logs and ingest into SIM. Just reduce, filter out as much as you can without filtering out too much that you want to see. But it really depends on the environment, what type of events and data you want to see in Splunk and how much data volume you can actually ingest. Some people may actually use an ELK stack instead of Splunk and ingest much more data because Splunk you actually have to pay for how much data you put in. I'm not sure if I answered the question fully, but we can discuss later.
Okay, thank you.
Thank you.